Okay, for homework 1, we had 3 transfer functions, and we were asked to write the corresponding differential equation. So this is part A right here. You know, the first intuition you might have would be to do a partial fraction decomposition on this term right here. But there's actually an easier way, because that does get fairly complicated fairly fast. And that is to multiply this out and then take the inverse Laplace transform. What we can do is we can multiply the f of s by 7 and our x of s by the polynomial on the bottom. And so we end up with x of s times s squared plus 5s plus 10. Okay. Is equal to f of s times 7. Cool. Yeah, that makes sense. And so now all we have to do is take the inverse Laplace transform of each side, and that'll yield a much simpler result than what we'd have done if we tried to do a partial fraction decomposition here. And the reason we don't have to do a partial fraction decomposition is because this side is still split up into its 2 terms. If we were trying to do the inverse Laplace transform of the response, so in other words, we plug something into the input, then we would end up with, you know, some trigonometric or, you know, the solutions to the differential equation. But in this case, we just want the differential equation, so we can multiply it out and make it easy for us. So this x of s is going to distribute out. So we can just go ahead and write the inverse Laplace transform as d squared x over dt squared plus 5 dx dt plus 10x is equal to 7f. That's it. So yeah, we got a second order linear differential equation. Pretty simple. It's not as complicated as it would look when you take your first glance at it. And so the rest of them can be solved this way too. So let's do that. So part B was, we had our x of s over f of s is equal to 15 over s plus 10, s plus 11. So we can multiply, y'all can't see my mouse pointer, but we can multiply, we can multiply these 2 terms together to get our polynomial that we want. So that would be s squared first plus, let's see, outer, inner, so it's going to be 21s plus 110. And then our top will still be 15. So did that right? Yeah, that's right. So then we can do the same thing and we can multiply out our x of s and our f of s. So what we end up with is, so we have x of s times s squared plus 21s plus 110, and that is equal to 15 f of s. Then we just take the inverse Laplace transform. So, you know, s squared, that's the double derivative. 21s is 21 times the derivative. So we'll just write that out as d squared x over dt squared plus 21 dx dt plus 110x, and then that's equal to 15f. And according to the solution manual, that is correct. Cool. So let's move on to the third part. Part C. So part C was, okay, so now instead of a number on top, we have an S term, so that's going to make things a little bit more complicated. But we have x of s over f of s is equal to s plus 3 over s cubed plus 11s squared plus 12s plus 18. So a little bit more complicated, but not that much more complicated, because we can still do the same thing and multiply everything out, right? So we'll end up with x of s times s cubed plus 11s squared plus 12s plus 18 is equal to f of s times s plus 3. Again, we'll distribute out our functions as we do the inverse Laplace transform. So now that we have that, all we have to do is write d cubed x over dt cubed plus 11 plus so that's what we should end up with. So now, if we wanted to solve this differential equation, that would be different. But they're just asking us to put it in, write it as a differential equation. So we just take the inverse Laplace transform, multiply everything out, and this is what we get. So that's homework 1, not as bad as it probably seemed. Now I'm going to go make a video for homework 2.